Good afternoon, all, and welcome to the session 5 of TSDSI Technical Deep Dive 2023 conference. I am Akash Malik. I'm Engineer Standards at TSDSI and coordinator for this session. Today's session is on 6G Open and Resilience by Design. Now, before we move ahead, I'd like to remind you of some of the quick points. All attendees will be kept on mute and throughout the session by default. If you have any questions for the speakers, please type them in the Q&A tab. Questions to the speakers posted in the chat box will not be entertained. You may interact with the fellow attendees live using the chats tab during the session. If you want to enlarge your presentation, please click the expanding arrow icon on the top right of the presenting screen. The tool is configured for HD video. You may switch to low definition or LD in case you are facing bandwidth problems. This webinar is being recorded and will be posted to the TSDSI website within the next few days. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can use the lounge facility for networking. The lounge will remain open till the end of the conference. Now, this is the session schedule where we have two keynotes followed by a panel discussion. The session will start with the welcome address from one of the co-chairs and then a closing address and the end of the session. Now, I would like to introduce you to the session co-chairs, Professor Arzad Alam Kirani from IIT Bhilai and Ms. Nishi Mundra from Vodafone Idea. Dr. Arzad Alam Kirani is currently the chair of the TSDSI SGSS Working Group 2, Applications and Service Layer Net Standards, AIML. He is the associate professor at IIT Bhilai. Welcome, Dr. Arzad. Ms. Nishi is the GM IoT platform and applications for a Vodafone Idea IoT business. Her mandate is to formulate integrated IoT platform and application strategy, product GTM, and pricing to drive revenue growth across various horizontals. She also heads the VI IoT Lab, which is an initiative run in collaboration with CDOT to promote interoperability and standardization in the Indian IoT ecosystem. Welcome, Nishi ma'am. Now, I would like to request Professor Arzad to start the proceeding with giving the welcome remarks. Over to you, sir.
Thanks, Akash, and thanks to TSDSI for inviting us to put together this session. So, as everyone knows, we are transiting into the planning phase for 6G, and even though 6G is itself very open right now, we are essentially convinced, most of us are convinced that there will be some open and resilient by design concept coming in 6G. So instead of attempting my own, giving my own interpretation of open and resilient by design, I will allow the other speakers in this session to share their experience and their own vision and views on what is meant by open and resilient by design. So thanks to all the speakers for having accepted our request. So Dario and Ishan and all the panel members. So without delaying further, I will request Dario. I guess I'll hand over to Nishi, who is the co-chair, to conduct the session. Thank you.
Thank you, Professor Arsad. And thank you, TSDSI, for giving us this opportunity. So, without wasting a lot of time, we'll move further and let's dive into this session of 6G where it gives us a lot of possibilities of what 6G can do. And I'll first invite our first keynote guest for the session, which is Dario Sabella. Dario Sabella works with Intel as Senior Manager Standards and Research, driving new technologies and edge cloud innovation for the advanced systems, involved in standard ecosystem harmonization and coordinating internal alignment on edge computing across SDOs and various industry groups. He is the chairman of HC MEC ISG and also He also acts as a company delegate of 5G Automotive Association. So, Dario, over to you.
Thank you so much, and thanks for inviting me. I guess you can hear my voice. I'm going also to share my screen. I prepared some slides for this talk. Okay, maybe in presenter mode will be better this way. It's fine from your side? I hope so. So let me start without any hesitation. I'm pleased to be in this session, which is on 6G open and resilient by design. Um, I, I, I believe this is a very timely opportunity for us to talk about Mac and edge computing standardization, because actually this is the period where we are planning the next phase of work in Mac, which is starting next year, from 2024 to 2026. So the time horizon will be perfectly in line with the evolution toward the 6G. So it's a very good opportunity and very timely. Quickly, you will see from me just some pointers, not an extensive presentation, but an overview of the activities that we have and the standards and the approach of the open standardization in ETSI multi-access edge computing, and also some not traditional activities more related to the development, application developers, communities, engagements, including open source collaborations, hackathons, sandbox and pokes and trials and plug tests and so on, and also an overview of what can be the transition toward the Mac Phase 4, paving the way toward future 6G systems. So very quickly, for who still doesn't know what Mac is about, you can see in this slide, actually, this is a group I'm pleased to chair, counting a number of members and participants from the industry, very diverse in the ecosystem, from telecommunication operators, but also technology providers, cloud providers, infrastructure providers, IT companies, software companies, application developers, startups, and some governments as well, and associations from vertical segments. So I believe this is a very diverse ecosystem. I'm pleased to chair this group, and the membership is growing continuously. We are building on top of the definitions from virtualization in NetNFV for the infrastructure part. For the application development part, there's a specific need to address the needs of developers and software development communities. And we are also access agnostic, so multi-access edge computing is the acronym MEC. It's really leaning on cellular networks, but also Wi-Fi and fixed access networks. So we are establishing links with diverse and different organizations on that. Of course, for the cellular revolution, we are aligning closely with the 3GPP. So you can see also a video on Mac produced by Etsy, and that purpose to explain to the wider audience what we are doing in Mac. But in a sentence, if you want to define Mac, this is a standard offering to application developers and content providers, cloud computing capabilities, and IT service environment at the edge of the network. And we are focusing on problems from the application developer side. And as I said, the standard is access agnostic, based on virtualization, aligned with 3GPP when it comes to 5G, and also addressing the needs of multiple vertical market segments. There are a lot of specifications and a lot of work done so far in this area. But I'm pleased to say that, of course, we are trying, of course, to establish a relationship between Etsy Mac and various organizations, because since Mac is serving different use cases, we want to need to listen at the needs from the vertical market segments like automotive, industrial automation, via AR, video streaming, gaming, and so on and so forth. And then we are establishing a dialogue with them because maybe the domain of expertise coming from those vertical segments is a source of information that tell us which are the pain points from application development point of view and the needs from these kind of vertical segments to retrieve information at the edge and expose at application level, which is meaningful and useful for them to build their applications in their specific vertical market. So we are not aiming to become experts of all these domains, not at all. We are the MEC experts, we are doing the MEC standards, but we need to listen at their needs from their vertical segments to understand what is appropriate to be standardized and exposed at the edge at application level. So you can see that, of course, our standard, starting from the infrastructure and the definition of the architecture, is defining some APIs. Essentially, the tool for exposing information at the edge at application level in the Mac app is to expose APIs. And we are defining different APIs as well for the lifecycle management and operation and interaction between the device application and the Mac system, and also internally for the orchestration part. But of course, I believe the work started a lot of time ago, I would say in 2015 with Mac Phase 1, establishing the infrastructure and also expanding to the addition of multiple APIs, clarifying the deployment in NFV environments, expanding from mobile to multi-access, adding Wi-Fi, fixed access APIs, starting with the work of testing and compliance test suites, and then in Mac Phase 3, starting 2021, when I was pleased to be chairman of this group, we expanded again the scope toward the heterogeneous clouds with the Mac Federation, inter-Mac system communication, Mac to cloud, and also Mac security, other kind of deployments, Mac in Park enterprises, and we are also studying Mac application slices and other work on abstracted APIs for vertical and industries. So actually, this is a really good phase because we are setting the scene as well for what is be the evolution for the future systems. I will tell you in a minute. Now, this is actually the plan. And the current working items, some of them are, let's say, appropriately finishing the current phase 3 of the specifications. Other working items are actually exploring new topics, like this Mac 47 distributed edge network is exploring also an evolution outside of the Mac phase 3, of course. And other topics like abstracted APIs can be also relevant for the future normative work, just to mention a few examples. And as I said, how we extract value from the edge and expose information that is suitable and usable by applications. The tool is API. So the APIs are one of the essential parts that we are standardizing at CMAC. We are not pretending to standardize all possible APIs. That would be too much, and by the way, not realistic. These are just exemplary implementation requested by the industry to be standardized. And there is also the possibility, actually, to open the market to new APIs. You don't have to knock at the door of the ETSI to standardize your own API, but any API, in principle, can be added as long as it is compliant with the basic Mac API principles. I will tell you in a minute. But this is actually very important. Let me just emphasize this, because this is the open approach of the ETSI. We don't have to do everything within the area of the standardization. And the mechanism of the entire platform, the exposure of the functionalities, yes, it's standard. But the actual functionalities will be driven by market needs. And also this is opening up the market to third parties and software companies that can build middleware services and open up the market and also increase the total addressable market of the edge. And this is where the edge value resides, essentially. So this standard is very open in that perspective. So let me explain how. Practically speaking, Mac applications can offer new services as well, not only consuming services. And this is the way we are conceiving the standard, and then we can allow to extend the Mac system by adding new functionalities. This is by design inserted in the Mac platform capabilities and service registry as a capability to recognize new services available. So the basic rule that you have to follow if you want to add a new service is to build a Mac application, and that is providing a new service, offering a new Mac service that can be exposed to the platform. And this is done as long as you comply with the basic principles for design, as I said before, and there is a Mac specification, Mac 009, explaining you essentially the rules using RESTful services and all the basic aspects related to the API design. Actually, it's a very common, universally recognized language, so it's really the language talked by application developer communities. So it's really an open approach, and to further stimulate the consumption of existing APIs and play with them and understand how to build new services, we are also making some efforts to offer a free tool, which is the Mac Sandbox, that you can try if you have even a free GitHub account by yourself. This try-mac.etsy.org, and then you can let's say understand how to use the APIs and maybe also to consume new Mac services. And then, as I said, we are expanding the phase 3 with the Mac Federation. This was starting from industry requirements from GSMA on this telco edge cloud concept, and we have published in a first of its kind a very first report on Mac Federation, studying this in 2021, defining this as a federated model of Mac systems enabling sharing usage of Mac services and applications. And this was driven by the need to expand from initial phase where we had intra-Mac system communication and also inter Mac system communication Mac to cloud. So actually this is the green area where we are expanding our scope in Mac phase 3, and this is really indeed the scope of the Mac Federation, where we have different stakeholders working together with different platforms that can be also heterogeneous, and collaborating together to expose and consume shared services and applications. And we are moving since the time of this 2021 report to the normative work. We published some specifications on that, Mac 40, Mac 003, and use cases for the Federation very quickly. But just to give you the flavor in real cases in the smart cities, this is really the case where you need a federation, because you cannot pretend, for example, in a city to have all cars from a single car manufacturer, or connected cars connected with a single mobile operator or with a single vendor. In general, the most general case is really diverse and heterogeneous case when we have multiple operators, multiple vendors, multiple car makers. And this is the case where you need to establish a Mac Federation. Otherwise, you cannot, let's say, build end-to-end any service to the customers. Okay, so this is another example of immersive AI AR gaming. It was showcased also by some operators in Asia. Actually, it's quite understandable also for gamers. They have their own internet connectivity and maybe mobile connections with different operators, and you need low latency connection to establish this kind of end-to-end link, also to guarantee the service required and the quality for gaming, for example. So again, here we need a federation. And yeah, we're not going into details, but actually we updated our architecture and also very carefully aligning with the 3GPP, as I said, when it comes to alignment on 5G. But really, the Mac Federator is the role that covers this kind of GSMA OP role of federation manager, federation broker, requested by the telco edge cloud requirements. And we are setting up all the means related to also Mac Federation enablement APIs in another specification, which is the Mac 40, published the first version in February 2023, and now moving to a second release for second version for this Mac Phase 3 completion. We are planning to move to stable the version 3.2.1 by the end of this year, and covering all those kind of procedures related and needed for the federation in order to set up, of course, the federation, register, update the register, but also make system discovery, application instant discovery, make service discovery, and so on and so forth. Moving also to forward toward the collaboration with other initiatives on this area, I wanted to mention quickly kind of a nice news. Actually, recently we established a collaboration with the Camara project under Linux Foundation. They are an open source project. We are a standard body. So being aware of our differences, we want to collaborate in a complementary way. And of course, for those who are interested to know more, I'm very happy to give you more details, but there was a recent press release announcing this kind of collaboration. I'm pleased to mention it because it's very promising also for the future. There are a lot of companies interested in these kind of topics, and I believe it's very much important for the ecosystem. More in detail, exactly, APIs are a key aspect. We clarified how to use APIs both from ETSI standards, from 3GPP, from non-standard systems, and mainstream for this kind of API gateway and mechanism to consume and expose APIs is the CAPIF as a possibility, also adopted by some companies and also by some stakeholders that are also engaged in Camara project. So this is our view. I can also show you some other topics that are very hot for MEC phase 3, very important as well as security. We are exploring which are the state-of-the-art solutions, and also coming from other groups and standards from the industry available for the edge computing, but also we are exploring which are the gaps. And then we are trying to understand what can be the future work, normative work in ETSMEC to cover those gaps, which are also specific for the edge. A white paper here can give you some overview and understanding of what is the state of the art in that perspective on MEC security. Last but not the least, I believe activities to engage developers are quite diverse, as I mentioned. A lot of things to say, little time, unfortunately. One for all, I wanted to mention you hackathon that is going to its final phase in October in the OCP Global Summit in San Jose in California in October 17-19. There will be a hackathon hosted in this summit organized by ETSI, Linux Foundation, and OCP with some solutions from developers. That will be really a nice show as well. And there are a lot of activities. As I said, there is not so much time. I wanted to instead talk about the future. And white paper I would like to suggest to you as a nice reading that can give you a flavor what can be the future trend and the support of MEC for the future. Actually, the concept of edge native was first introduced by Linux Foundation in 2020. So it's not a new concept, but now it's mature time to think about how the standardization can support this kind of vision and move forward also by you considering the evolution of the infrastructure towards 6G. And so this white paper is kind of setting us the scene and the view from ETSI standard point of view of what can be the future. And talking about 6G, we have to be honest, of course, yet 6G is not a reality, of course, and nobody can claim I know exactly what 6G will be. And then for a better reason, nobody can say, of course, again, what MEC in 6G will be, just to be honest, right? But on the other hand, it's also very appropriate now to understand what can be the evolution and the vision and shape it and maybe plan the work toward this transition that will move forward in that perspective towards 6G. So it's now, as I said, the time to move to planning phase 4. And that's why we have approved recently a term of reference for MEC for the next term, which is 23 and 24. So setting the scene for MEC phase 4 normative work. That means that we can tell you already now which can be the topics at the transition from Mac Phase 3 to Mac Phase 4, just for your inspiration, understanding what can happen next, right? We are seeing a progressive focus on multi-domain and multi-tenancy slicing and Mac support for application slicing as well. We have a working item on that, by the way. And Mac architecture can also evolve by supporting cloud-native communication system and edge-native design for application developers, as I said. We see an increased interest on security and privacy, and also we will continue, of course, creating developer-friendly environments to attract better the ecosystem, maybe by using by software development in some cases, SDKs or other tools, and continue our outreach efforts and also collaboration with open source. This is more or less what we can say now, maybe not limitative of what can be in the next phase 4, but give you a glance on a look into the future. So I'm ending to my conclusion, and just in one sentence, Mac is a key technology that will support 6G systems with relevant standardization in the fields of federation, multi-domain, and multi-tenancy slicing, edge cybersecurity, and support of edge native design for application developers. And with that, thank you for your attention.
Thank you, Dario, for this enlightening talk on MEC and the work happening in Etsy around it and the various collaborations. I definitely more than agree that MEC is more than just a technology advancement. It's the foundational element for 6G. And collaboration across various ecosystem stakeholders and standardization is essential for it to become a success story. So thank you once again, Dario. Moving on, I invite Dr. Ishan Vaishnavi for the second keynote presentation today. He'll be speaking on opening networks from 5G slices to 6G applications. Dr. Ishan Vaishnavi is a 5G 6G expert with 20 years of experience in technology vision, management, and leadership. In his current role at Nokia Munich, he is leading a team focused on the monetization aspects of 5G and beyond networks based on supporting solutions that increase revenue on one hand, and in addition to automation solutions that decrease TCO on the other. Ishan, I invite you to the floor. Akash, if you could bring up Ishan's presentation.
Hi, so I will be sharing my slides. Give me a second. Happy to be here and thank you for the good invitation. Let's get started. I hope everybody can hear me okay. Yes. All right. So you can see my screen, I assume. And so I will be speaking, as Nishi said, and thanks for the introduction, by the way, on monetization and the way we see monetization here in my team at Nokia. It will be partly related to what, let's say, Dario already presented from a MEC perspective, but it will be more generic in its approach. All right, so let's get started. So let's take a step back and try to review if 5G has achieved its objectives. So what was 5G designed for? And I was involved in the design of 5G network slicing back in the day. 5G was designed for a B2B market predominantly, for addressing new service areas. So if you Google what was 5G designed for, you get this new service areas. However, if you ask Google what is new in 5G, you see that it only speaks about delivering bandwidth to UEs. It does not speak about new service areas. And there is this fundamental problem in the culture that we have in our industry on focusing on the UEs. So this is something we need to go beyond, above and beyond. And this is also partly true for 6G, the way we are saying it now. So this is the INT 2030 vision. It's very nice that we are going to look into integrated AI communication, high reliability communications, ubiquitous connectivity, massive communications, integrated sensing, that's going to be a cool new technology, and immersive communications. That's going to enhance a lot of things that we do day to day. However, there is something missing in my vision still from perspective of monetization. We need to improve market acceptance, and we need to be able to grow industry revenue as a whole, and these things go hand in hand. In a sense, we need to create more value, and as Dario already said, we need to increase the TAM, the total addressable market. Good. So, what is Nokia's 6G vision in this regard? So, we are looking at multiple 6G technologies that will be enabling 6G. And the key thing that I'm going to speak about is on the cognitive, automated, and specialized architectures. So there is, of course, AI native air interface, network as a sensor, extreme connectivity, security, trust, and privacy. We will look into that shortly, and spectrum technologies. But the focus for today's talk is going to be on specialized architecture and how do you increase market acceptance for those. So if you look at this slide, so this is somehow what 6G might look like. You will have at the lowest layer the infrastructure. At the next layer, you will have this the user plane and the control plane, and the radio network. And at the top of it, you will have different, let's say, verticals accessing the network via APIs. And then the part that we would be interested in is how these APIs work. How are they exposed? So how is information and APIs exposed to verticals? And that's what we are going to look at. What are the requirements there? What needs to be done? What is the Nokia vision? And what aspects on security need to be handled? So opening the network is not a new concept. It has existed back also in 4G. But if you look at the web results on how do I create my own cloud web page, multiple sites with clear step-by-step instructions appear on how you can create your web service on the cloud, and you get an instruction on Google and AWS free accounts. However, if you do the same search on how do I create my network slice, you get links to IEEE Explore and blogs about what network slicing means from very prominent researchers, and the links towards 3GPP work on network slicing. And if you're sharp-eyed, you will notice a small difference, but it's a rather important difference. The results that you get from search on the left are targeted towards customers. The results that you get towards on the right, when you do the Google search, are targeted towards researchers and standard experts. So there is a fundamental issue at exposing APIs and going and getting the B2B business going in telco that hasn't fully settled in. It's on its way, but it hasn't fully happened yet. And one of the aspects that I would like to address here is that we have many API endpoints. We just saw the Edge API in Dario's presentation. We have the NEF specified by 3GPP. We have ORAN specifying RAN APIs. And if you have a look, there is RF management API, AIML workflow APIs here, and different other types of APIs that are specified by the RAN. There are management APIs, and this is the MEC work that was just presented by Dario. This is the API from NEF. So this is 3GPP control and user plane exposure towards application functions. And you have the operations exposure towards application functions from 3GPP as well, but this is on the management plane. So in addition to this, and this still doesn't cover the work that has been done on GSMA, on TMF, and as we saw in Dario's presentation on Camara. So we have many APIs, and it's a bit chaotic, in my opinion, for somebody to understand what is the difference between the different APIs. What does an operations API do, which is responsible for lifecycle management, versus what do the network APIs do, which is responsible for addressing the end users, so the user equipment. So something needs to be done to improve this market acceptance of telco APIs. And this is where our vision comes in. And this is now a very generic vision in the industry that we are working towards. Exposure, the clouds that you see below are different technology domains. So you have cloud, let's say MEC exposure, 3GPP core exposure, RAN exposure, and they will be integrated into a value-added network platform, which will then expose APIs towards applications in the verticals which are abstracted. So I'm aware of, for example, the abstracted harness work going on in MEC, which Dario presented as well. There is also work in Camara on this. So this is something that needs to be inherently built in 6G, in my opinion. In addition, these APIs need to be focused in the sense that they cannot be very huge. They need to be address one use case at a time. They need to be abstracted and simplified so that an app developer does not care whether he's addressing a mobile network or a mobile node or a stationary node, or what kind of handover optimization is being done, where the node is located. The app developer only cares about the functionality that is relevant for his application. And this can only be done by speaking to different app developers, to different industries on a one-by-one basis. So Nokia has a vision here where we have efforts towards what we call network as code, where we plan to develop an ecosystem where we bring together hyperscalers, enterprises, developers, consumers, and CSPs all together, so that we can create this ecosystem that can address the different verticals that we are looking at. We are looking at first responders, we are looking at Web 3.0, at V2X, so vertical networks, different marketplaces, transportation, Industry 4.0, of course, finance is a big one, and metaverse. So we need to be able to create these different ecosystems that handle the requirements of those industries and abstract the network away. So this is a vision that we have towards 6G, and we are already working on it in 5G as well. So this is an ongoing process. However, this brings, while opening the network, you also bring new threat vectors in. So you now have billions of endpoints, different devices, millions of subnetworks, because each vertical, each developer could have his own subnetwork. You will have open interfaces. This is what we are proposing now, and disaggregation, which means you're increasing your surface of attack. You have different infrastructures, so not everything is under your control. You have on-premises infrastructure, private infrastructure, public infrastructure. You need to take care of that. You have multi-vendor approach and open source and private and proprietary software working together. So you have a multi-stakeholder supply chain and a different dynamic runtime environment where you need to handle the threat vectors. So the only way to do this is the different enablers that we are looking at towards handling the security issues. So we need to have AI/ML-based security auditing. We need to have secure AI/ML-based operations, so active AI/ML that is monitoring the network. You need to be authenticate different people and in a scalable manner, so not just centralized authentication, but distributed authentication, but that has to work somehow in a secure manner. You need to be able to trust systems. Security needs to be ultra fine, so you need to be able to respond to individual attacks, not just shut down the whole network. You need to handle data privacy. Europe is very strict about data privacy. German data must stay in Germany, or at least in EU. And we need to handle the changes that come from quantum computing. So not just an open network, but also a reliable and secure network. We need to handle both together. So what is my takeaway in this whole short talk at a high level? We need to remember as an industry, as a telco industry, that the culture that we have of being closed and bounded, that is going to eat any strategy of opening the network for breakfast. This is a well-known phenomenon in management, that no matter how good the strategy is, if you don't have the culture to support it, your strategy will be eaten. So we're talking about increasing the revenues, increasing profitability, and increasing the total addressable market. So we can divide this into increasing revenue and reducing costs, and we will ignore the other financial aspects of balance sheets for now. But at increasing revenue, we speak about network exposure, where we are able to expose the network to different verticals, opening up the network. We need to do this. This is something we haven't done as an industry, and we could have done it before, but we need to do it now. And it's, in my opinion, it's now or never. That's my personal opinion. And we need to reduce costs. So this is what my team works in day in and day out. We have a part of the team that works on network exposure. How do you do APIs in MEC? How do you do APIs in SA5, in 3GPP? How do you do APIs in SA2? Working on Camara in TMF. And the other part of the team works on reducing costs. So how do you use AI ML and closed loops for automation? So these things need to go hand in hand. But there is a part in the middle where culture comes in, and that is we need to do continuous innovations. It's not enough to just say we opened the network and we automated the network so it will all work itself. We need to continuously innovate. And an example of our, let's say, ignorance of innovation to some extent is CSP spent 0.8% of their revenue on R&D, whereas hyperscalers spend 16% of their revenue on R&D, and hyperscalers have significantly higher revenue to some extent. Innovations are not just restricted to R&D in technology. Innovations also must handle business models. So partnerships, platforms, ecosystems. It's no longer just I create this product, I create this service, and I will sell it. But I create this platform and I bring in a partner service which I will help sell into my network. If you remember I like to mention the Ache when I was a little kid. That was a Doordarshan broadcast here. That holds true very well today in this environment. So for the younger folks, Ache is something you can Google on the network, on YouTube, and it's a must see for my generation. In technology as well, we need to move towards a culture of agile methodology. We need to be faster. We cannot always rely on everything being developed to its best effort. We need to keep it secure, but we need to do it faster. And we need to develop a sort of a supply chain where everything that is standardized, for example, in MEC, for example, in 3GPP, quickly shows up in the network. So this is something we need to do. And this is a culture change. This is something that we need to do as a technology. Finally, everything needs to be secure by design. Security is the first citizen in all of this design, because if you want to expose your network, if you want to open up the APIs, if you want to automate, you need to have security. Otherwise, this stuff will not work. That's it for my talk. This is the takeaway that I had today. It's at a high level. So if you would like to have questions or in-depth discussions, feel free to reach out to me. I'm available at that email address, and you can, of course, Google me or search me on LinkedIn. Thank you very much.
Thank you, Dr. Ishan. And we completely resonate on the fact that technology could grow multiple folds, but unless there is a plan to quickly monetize it, it fizzles out as quickly. And true
Absolutely.
that with openness and with open APIs, with integrations comes in a lot of complexity. And for this technology to be adapted and adopted, reducing the complexity, reducing the, mitigating the vectors, threat vectors, it's necessary. So thank you once again, Ishan, and I invite Dr. Arshad now to moderate the upcoming panel discussion. It's a very interesting panel discussion on 6G open and resilience. And over to you, Dr. Arshad.
Yeah, thanks Nishi, thanks Ishan and Dario for interesting updates on the tools which are expected to enable future open networks. Uh, as Dario also pointed out, and Ishan has also been talking about the applications part. So just opening the network will not be the objective. It's the end objective is to be able to support something over that network, which is right now not very clear to all of us. There are some discussions already there. So I hope that the panel members today will help us understand various aspects around opening such a network. Our first speaker is Akash. Can you please share Dr. Summers' profile? Yeah. So the first speaker is Dr. Samar Shailendra, who is currently senior lecturer at Melbourne Institute of Technology, Australia. He's also an adjunct faculty at IIIT Bangalore. And he has done a lot of work on standardization and related aspects while he was at Intel and also at TCS. So I request Dr. Samar to share his thoughts on open and resilient networks. Dr. Samar, over to you. Maybe 6 to 7 minutes. Thank you.
Yeah, thank you, Azad. Can I share my presentation? Is it possible?
Go ahead, sir.
Yeah. Just give me a second. I hope my screen is visible.
Yes, Samar.
Okay. So, um, okay, I hope it's visible all right, because to me somehow it's not really doing very well.
I can see five slide deck, and the first slide is visible, Samar.
Okay. So,
Please go. We can see you and your presentation as well. Thank you.
okay. Okay, perfect. I'm not sure if it is going in the full slide mode, but somehow it's not allowing me to change it. So I'll probably go ahead with this. And so thank you, Azad. Thank you very much for this kind introduction. And we had very interesting thoughts from Dario and Ishan about 6G MAC. I mean, the MAC, which probably may be culminating into some form in 6G, and how moving from 5G to 6G require that we have enough visibility and the monetization happening. And as part of this panel discussion, what I want to look at is that how 6G can be converted into reality, what we have the thoughts today. And I completely resonate with the fact that we are, you know, looking at the open network, the resilient network, and this all has to happen by design. It's not just that we are thinking that the 6G can become open and we can probably make our networks, make available to the people around. Like Ishan mentioned, that it has to go by design, and it has to be able to have handle the complexities which are coming because of this openness. So looking at what it's on here, can I try sharing it once again? Somehow it's not working all right for me. Yeah, I hope this is okay. So what 6G is, if we look at what ITU has been doing, they define the characteristics, which talks about the inclusivity, ubiquitousness, sustainable. It should be innovative, secure, standardized, interoperable, and it should support interworking. This kind of characteristics lead to the trends and the scenarios, which has been ubiquitous intelligence. Your network should have the trends like it should be intelligent, the computing should be ubiquitously available, the connectivity should be seamless, and the kind of user applications which are emerging are more immersive by nature. Yeah, we see a lot of use cases like digital twin, digital health, and a very fundamental thing happening is the integrated sensing and communication and sustainable. And how do we achieve that? Of course, I believe to some extent we have to enhance the technology, whether we talk about the interfaces, whether we enhancing the networks, whether we talk about enhancing our spectrum, because it's probably not possible unless we have enough spectrum available. Uh, we can do much about the kind of data latency demands we are happening to us. So, in its own vision, which IMT or IMT 2030, which ITU has kind of agreed upon, is the different usage scenarios. Some are the enhancements from the existing 5G, which all of us have been talking about, is in terms of the hyper reliability, immersive communication, and massive communication. But apart from that, there are some new capabilities which has been agreed, or new user scenario which has been agreed upon. That's the integration of the AI, especially with the communication. So you have, the joint AI communication happening together. A ubiquitous connectivity, that's a slightly tricky topic in my opinion, but yeah. And then integrated sensing and communication. And this lead to the capabilities which we want from our 6G or IMT 2030, which has spoken about, is the interoperability, sustainability, a ubiquitous coverage, and the capabilities related to AI sensing, etc. Now, what I want to bring the focus upon is especially the keywords like ubiquitous, integrated, interoperable, sustainable, and ubiquitous coverage. If we put everything together, if we want to achieve this, I don't think there is any way other than to make your network open and you build a network and the system which is more sustainable in nature. We are already seeing the trend, which Ishan and Derry also mentioned to some extent, whether you'll see in terms of the Open RAN initiative, whether merging of your or virtualization technologies within your network. You look at the APIs, the way Camara and everyone is moving towards. So I think that's the way to go. Everybody is kind of realizing it. And if I put everything all together, so I see the intelligence is the at the center of everything, and it will bring the communication, sensing, reliability, etc., and the massiveness together. And that means the way 6G probably is going to happen broadly is it will be more data driven. It will talk about the ubiquity that you have everything in place. It should be secure. There is no other choice, and it should be very sustainable. So when I say the data driven, it's the data should be owned by the user, not by anyone else. So the issues like privacy and things like that should be taken care of. The access of network has to be software driven because we are talking about the unified network. So network has to bring all the technologies and access together, whether it's terrestrial or non-terrestrial. The technologies and the application should be plug and play based. They should be very much on demand. So, it should become very seamless. As Shan also mentioned in his talk that, as a user, I just bothered about the APIs. I don't care what's happening at the bottom. I just be able to plug and play it. And last but not least, it has to be secure by design. There is no way to go other than that. Till now, even in 5G also, we have been talking security a lot, but it didn't happen by design still. It still is a fairly overlay. So now it has to go as part of the overall design process, and that's the way I believe 6G is going to be. So yeah, with that opening thought, I'll probably stop here and look forward to the other speakers, and yeah, we can have a nice discussion around what others feel about it. Over to you, Arzul.
Thanks a lot, Samar. Thank you. The format that we have is that each panel member will first speak, and at the end we'll have Q&A. So I'll request Akash. Can you? Our next panel member is Sandeep Sharma, who is VP and Global Head of at Tech Mahindra. He has a lot of experience on on the uh, deployment aspects as well. So I'll let Mr. Sandeep Sharma share his thoughts on what we mean by, or what he means by open RAN in this case.
Yeah, thanks, Dr. Asad, and thanks, Dr. Summer, for setting the context about 6G and what is expected out of it. But on the back of my mind, I was just thinking, as we evolve with technology, we all become so greedy out of, or we become so over ambitious out of technology that we are expecting so much out of a single technology with from 6G, and it's not because something came out suddenly. It's because based on our experience from the previous technologies as well. So by now, I think if I summarize the learnings that we have today so far from the 6G, so we discussed different imperatives of 6G and what the legacy technology were able to achieve and what not. And by now we understood that what IMT 2030 vision is and what different industries expect out of 6G. If I summarize all those discussions that are happening around and today's discussion as well, all those discussion can be summarized in six focus areas of 6G. One is the unified access. Unified access not only having a ubiquitous connectivity, but also having a sensing and communication together in the same network. Next important aspect is affordability. This calls for a diverse ecosystem and extreme level of automation, a next level which we are achieving today in our 5G networks. Certainly, every G starts with a new spectrum, or I would say additional spectrum. So even though we talk about new spectrum, the legacy spectrums or the low bands will still make a lot of sense. Next, I would say is about the native AI. AI creating a lot of buzzwords today. It's already started happening in the network, and to a certain extent, one form or the other AI we are already using the networks today. But with 6G, it has to be more native or design driven. So every node should have certain AI inbuilt into it, and it has to be more real time. Next is sustainability. Just we need to abide by the UN sustainability goals, either by a technology or enabling other industries so that we can achieve a zero carbon footprint. Finally, but the most important, security. I think Dr. Ishan talked about it and other speakers talked about it. Like, however, how robust the security system should be, it also is defined by how the adjacent ecosystem is also evolving around security. And since lot many components are again going to be virtualized, open, security by traditional means may not remain relevant. We need to look at quantum way or quantum key distributions here so that systems can be more secure. But all these expectations are is not set by one industry or one standard. So if you look at let's say different standards bodies, 3GPP, NGMN, all these are putting together, and these industry alliances also putting into place the operator's perspective or the industry perspective, so that all the unification could happen and the standards could come out in a more defined way. But one thing is very crucial here, that having so much expectation met by a technology which is closed ecosystem is possible. I don't think so. We need to have an open and resilient ecosystem to achieve all these different goals from 6G. Next. If you look at Open RAN, Open RAN actually changed the way we look at the RAN networks. Virtualization was happening in the core networks where RAN was being a more closed ecosystem. It has changed now. It is saying now we are talking about virtualization. We are talking about disaggregation of hardware and software, having an open front hall. All those things are creating a different, I would say, perception or different philosophy of deploying networks to achieve more and more efficiencies and generating intelligence out of it as well. But ORAN is not something which is only open. As we evolved, ORAN is an intelligent RAN network as well. The concepts of RAIC, non-real-time, real-time RAIC, all those are creating a AI layer into it, and that has a probability or possibility to evolve to a native AI. And if you look at what 6G vision about ORAN or ORAN Alliance has, or from the ORAN as a technology is, that the fundamental pillars will always remain the same. It has to be open, it has to be interoperable, virtualized, and intelligent. So open and intelligent or self-driven type of networks are the vision that OpenRAN believes in the future will be. And Open Alliance is so much focused on it. There's a separate focus group which is formed around NGRG that not only focuses on different new ways of doing things, also benchmarking or creating collaboration across different standards vertical so that the best of technology should come out in the market. So identification of the gaps, creating an impact, doing an impact analysis, aligning with the standards body, and then implementation part of it. Next. Another important thing I think we all should be aware of, the way we are evolving with the technologies, networks are going to be more and more complex. Managing networks with human intervention will not be an efficient way going further, and affordability can't be achieved, and the innovations can't be achieved if we don't think AI about it. Not only think, we have to implement AI by design. If you look at today's network, I think AI is there, but it's more on a centralized fashion. For example, if you talk about today's SON networks, a certain level of AI exists, or if you can compare it from the ORAN ecosystem, it's basically non-real-time, I would say, rig that exists. If you move to distributed AI, where every node has its own AI as well, uh, it talks about more of a near real-time rig, which is having intelligence moved away from radio to a common edge. But the 5G advanced onwards, it can't be an isolated AI. So till now, we are talking about only network taking a decision on the AI. Going further, it has to be a collaborative AI that will shape up the future, where we have a cross-layer AI or cross-node AI, where device will also take an AI decision, network will also take a decision, and whichever decision best suited for the particular instant or condition will supersede, and we can achieve the efficiency out of it, either in terms of optimization of the resources or allocation of the resources. Finally, the ultimate aim that 6G should look at, or I believe will be, the native AI by design, so that every node will take its own AI, take a real-time collaboration with the network components, and that will help in achieving the resources optimization or use case realization in a more intelligent way. And AI is not only from the optimization perspective or resource allocation perspective, AI from the perspective of the security as well. So more and more AI distributed across network can analyze the data patterns, can analyze the threats, and can take in corrective actions and train the models accordingly so that the future threats can be avoided. Next. So if I summarize, what are the key takeaways is that whatever we are planning for 6G, we should leverage or the learnings or the mistakes that we have done in the previous generations of technology, making it more and more robust, open, and resilient as we go further. Since lot many expectations out of this technology is the single technology, single standard may not be sufficient. We need to look at collaborative approach, how the different industry verticals, different standards collaborate to create a unified view of the technologies that can be given in an affordable way to the customers or the industries. It can't be centered only about CSPs. It is focused on CSP challenges as well as the industry challenges as well. And to satisfy all these things, it has to be open and interoperable. Finally, AI is the central theme around it, and the more and more AI we use in the networks, the more and more efficiencies we can achieve out of it. That's summarize my presentation. Open to discussions or questions if anyone has as we go further.
Thank you, Sanjay, uh, for the interesting discussion. Now I will request Professor Brajesh Lal from IIT Delhi. So, who has so Professor Lal has significant industry as well as academic experience, and he is actively pursuing the edge aspects in standardization in 5G as well as in 3GPP as well as the TSDSI. So he's aware of the evolution of standards around this aspect. So I'll request Professor Lal to share his thoughts.
Thank you, Arzad. Thank you for the introduction. And so today I'm going to give a different perspective. We've been looking at 6G evolution from the high level. Here we'll pick up an application that might become popular, well, it is slated to, haptics, and see how it incorporates resilience and openness, and why that is absolutely necessary for haptics to become more commonplace. And while we are at it, you'll see that MEC and AI/ML seem to be also the kind of drivers that will make it happen. Can we move to the next slide, please? Right. In interest of time, I just skip the agenda. Next slide, please. Right. So let us understand what is it that we are trying to do here. We are looking at teleoperation, which means that you have either autonomous or assisted control of the remote environment. In case of assisted, you have a master controller, a human in the loop, who will send information or control packets or messages to the robotic arm, hand, or whatever endpoint you have to perform the task at hand. In case of autonomous, the decisioning will also be done by the endpoint itself, which is in our case the robotic hand, for example. So you have a bilateral teleoperation. The human exists as a controller, and in the other direction, what he receives is feedback. When the robo performs a task, there will be a feedback. For example, when you're trying to lift something up, you might notice slipping happening. Now, slipping of the object could have consequences such as breakage of the object that you're trying to lift. So what happens here is that the latency requirements is extremely high, as is the availability requirement. So, what in this particular case happens is that the communication media has to ensure that there is both resilience and there is high degree of performance capability in the network itself, so that the messages from the controller arrive on time, the feedback reaches the controller in time, and in case the message from the controller cannot reach the remote device, there is capability in the endpoint to take some necessary actions which can take care of some mistakes not happening. Next slide, please. So what is it, where does it fit in case of 5G? Because in 5G you talked about enhanced mobile broadband and also about ultra reliable low latency communication. Haptics takes it to the next level. So you need a high broadband communication, because the bandwidth is based both the bandwidth requirement is driven both by the haptic feedback and the visual feedback for a lot of tasks. So a high bandwidth is a given, but you also need very, very high reliability and low latency, because haptics is a task which is even more latency critical than video was. So for this reason, what happens is that ultra reliable low latency paradigm is pushed to its limit, and to some extent there is a demand on high bandwidth as well. Next slide, please. So how is it currently done? In the traditional method, what you'd have is you'll have a controller, a human controller, or a software sitting at the cloud or the server end, and you will have some local computational capability. Obviously, at the local or the endpoint part where the robo is, you will have capability to perform only small amounts of computation. At the remote end, you will have capability to perform much higher computations. However, the problem is that it takes some time for it to arrive. And the second issue is that at times it might not even arrive, which means that the resilience might be compromised. So in such cases, as you move to an application which will be quite hopefully quite native in 6G, where there's talk of immersiveness, where there's talk of automation, where there's a talk of more control being given to machines, haptics will play a central role. And it will also lead to something that we understand as the convergence of control into the already converged com and compute scenario. Can we move to the next slide, please, just to see how we handle it? So some methods of handling it, and this is not the only way we can do it, is split control of AI/ML. So you could have some part of the control on the endpoint, some in the edge, and some in the cloud. And accordingly, the model and the data will have to be distributed along these three entities in the network, which then gives rise to the need for distributed and federated learning. Now, the reason I'm talking about all of these examples is because if we move to the next slide, all of this needs us to have a design which is resilient. Because what happens in haptics is that the ultra low latency communication requirement would need that you have the capability that by design you have a network which is one, highly capable, and two, resilient to problems that might occur. Then there is this need for handling precision. There is also this need for auto corrective measures, because what sometimes might happen is that the connectivity might break or slow down, in which case there should be capability in the endpoint to be able to take corrective actions, which means that resilience by design is a requirement rather than a good to have feature. If we move to the next slide. So here, what we are giving is an architecture that can make it happen. Then again, this is not the only way one can achieve it, but since there's been talk of MEC and people realize what edge computing is about, edge is one mechanism to handle this scenario where you distribute your capabilities amongst the endpoint, the edge, and the cloud, which is typically for non-real-time decisioning, or if in case the network's good, also for near real time. Can we go to the next slide, please? And MEC might be a good mechanism to leverage this, and this is one of the ways in which we are trying to solve the problem in our lab here at IIT Delhi, and that is the reason why the slides present here. So for us, when we are looking at resilient, and I'll talk a bit about open in the slides that follow, we have put our faith in MEC as the architecture of choice. So there'll be capability right close to the endpoint to take decisions, and some of the more complex decisions which are not that real time can then be sent to the cloud for slower and more accurate decisioning. Can we go to the next slide, please? Right. So this brings us to the other point that we are talking about in the panel today, which is open by design. So there are multiple reasons for the need for openness in the scenario of haptics. The other speakers have already talked about the fact that there was this need to move away from services only for clients. You were looking for B2B kind of services, and there was this need for being able to build apps seamlessly and more easily, and there was need for openness there. Now if you look at it from the point of view of a typical application or typical capability that might get incorporated as a communication modality in the next generation, there are multiple reasons why it should be open. The first and the foremost is that there's a need for standard APIs. Today, what is happening is that haptic devices are being developed quite independently of each other. So even to get them to interoperate is quite a task. So there's this need for standard APIs and a need for evolving the ROS to move towards a mechanism where it just does not look at handling different kinds of device capabilities, but also at making it plug and play if you have to talk to each other over a network. Then the other issue that needs to be handled is that while there'll be multiple tasks with respect to the operating environment that you have, the device itself are being designed and developed independently, which is fine, but they should adhere to some degree of openness in terms of APIs which should be shareable to make them plug and play. So while the capabilities might differ, an easy way to understand it is that you might have cameras with different resolution, but at the end of the day, if you have the communication capability, you can plug in camera with any acceptable spatial resolution or a video frame capability. So something similar will need to be done here. We need to understand what it is that haptic devices aim to achieve, and what is it that can be made to be common across the different people in the industry who are making devices which are capable of performing haptic related devices. And the last area where openness will become important is in the way that data is encoded. Like with other communication modalities such as speech, text, and video, images included. Here again, there's this need for encoding the data and decoding it at the other end. And these encoding and decoding technologies should, one, be standardized, and two, because the devices are coming from a very large ecosystem, it might be a good idea to have it open for some period of time so that we are able to come up with encoding mechanisms which are robust and which are easily acceptable by a large volume of equipment manufacturers. Can we move to the next slide, please? So here, very quickly, I will go through the next couple of slides to explain what this interoperability is in context of openness. So, for example, the relatively simple setup that we have in the lab here has a haptic glove which has 11 degrees of freedom, and on the other hand, you have an Allegro robotic hand which has 16 degrees of freedom. While you need the two to interoperate, both of them can connect to the ROS, but you need to put in extra capabilities just so that they know what the signals to each other are. Here we are looking at the forward channel where you're sending control signals towards the robotic hand, and if we move to the next slide, what you'll see is the backward channel where you're getting feedback, haptic signals that come back to the haptic glove, and based on the feedback that you got, you make decisions about the next operation that you need to perform. Now here, clearly, if you want it to be agnostic to the equipment manufacturer, and if you want this ecosystem to grow at a fast pace, it becomes extremely important that the design is open, the APIs are standardized so that people can quickly build products and put them in the ecosystem. Can we move to the next slide, please? And for in interest of time, I'll skip this. Let's move to the next slide. The final slide, please. The slide that follows. Yeah. And here I'm talking of two ongoing work here at IIT because they give us an idea of why openness and resilience is important. One of the works that we're doing is latency aware algorithms for intent prediction. So even while coming up with algorithms, we have had to incorporate resilience in them. So the algorithm is being built to predict the intent so that this intent prediction is then used to make sure that corrective measures can be taken in case there's a break in service or some other untoward incidents happens. The other aspect is where you probably want some degree of openness is we are trying to estimate the shape or geometry of an object by haptic data alone. Usually humans, when they operate with the environment, they look at an object and they also feel and touch the object to understand what the object's about. uh, we are looking at the limits of haptics in terms of its capability to understand the environment around itself. But once you work on this, the need for open architecture becomes important because you need to have inputs which could either be audio, which could be video, or which could be haptics, and they should all point to the same object. So there has to be some degree of interoperability in terms of information from different modality translating into the same form as far as information is concerned. Yeah, so this is my quick take on openness and resilience with a real world example of a modality that might find its way into the 6G. I'll be happy to take questions later on in the panel. Thanks.
Thank you, Professor Lal, for sharing with us the concrete use case that you are working on and how it relates to the discussions that we are having in the panel today. Our next panel member is Dr. Abhishek Thakur. So he has a lot of industry as well as academia experience. So over to Abhishek. Thank you.
Thank you, Arzad. So thanks to TSDSI as well as the panel members and the keynote speakers. A lot of ground has been covered, especially the B2B aspects, open aspects. I'm quickly bringing in the perspective from banking and financial services, vertical specific inputs. Thanks to DOT and DFS, we started this journey more than 4 years back with some very high expectations as 5G use case labs for banking and financial services. Just like others, we have had unmet premises from 5G, which we hope that next few years, we may not have to wait till 6G, we will get some of it solved. So the first perspective, I'm breaking it into three perspectives. The first perspective is the enterprise architecture, wherein we were hoping, so banks or financial systems are slightly more widespread compared to say a manufacturing site where we could set up a private network. So we were hoping that there would be better solution spaces coming up as we get towards 6G to handle industries like banks, which are sort of omnipresent in the country. So besides telco and railways, potentially banks are the most widespread systems today for most of the global south. One key thing that interested the banking teams was ability to have a single control plane, both for with the convergence, both for endpoint mobility, cloud, and similar things. These slides are a set of expectations, I would say, and we are hoping that this gets realized in the days to come. Couple of challenges I wanted to bring in from the industry perspective. One was vendor lock-in. No bank would be willing to go into a 5G or 6G enterprise network with a dependency on a single telco or a single OEM. So how do we have a strategy coming in to have a good deployment without complexity that is, by the way, open systems are also bringing in a bit of a complexity as far as the business to business verticals are concerned. And then the technological stability around it, that also becomes very crucial. And finally, all of us are struggling with skilled peoples on these technologies. So in 60 timeframe, hopefully we have more India-specific skills built on it to really exploit slices and similar aspects with multi-telco scenario. The second input is, if we are looking at a 6G enterprise, how do we have a minimal brownfield deployment? Again, banking systems are heavily reliant on cybersecurity and other principles being met from day one. Running two systems increases the attack surfaces. So that is something that is a big risk for the industry as such. If we do not have a clear path that in 12 or 24 months, we would be moving from a brownfield to a greenfield enterprise architecture. Next slide, please. So as far as the customer experience, again from banking and open and resilient society is concerned, thankfully, we have had very good success as banking as an industry, thanks to the telco innovations over 4G. It gets built up on 5G. UPI being a classical example of something that has become inclusive, almost ubiquitous, as well as sort of the theme of connected society quite fits in there. Affordability is one aspect that we still struggle in India, though the ARPU is the minimum for us compared to world scale. But if you look from the digital and financial security for people at the bulk of pyramid, some of the innovations we have had, for example, for the railway travel, a 35 paisa insurance, or with UPI, zero merchant discount rate. Now, these are some of the paradigms that had we left for the Western card network providers, we would never have achieved. So how do we continue to build up on such scenarios and innovate our systems to be very cost efficient, keeping the rural Bharat in mind? The second aspect is around the majority of, when we're talking of human 6G or humane 6G, can we create technologies which are beyond just the device as an endpoint? Again, this was covered by Ishan as well as Dario and other panelists before me, to help people who are captured in the picture here. These are people who are traveling an hour to 2 hours to reach a physical branch, willing to wait 2 to 4 hours, and again traveling back for over 2 to 4 hours, or to get a renewal of their loan and things like that. Now, when we're talking of ubiquitous and inclusive with open systems, can we have applications that can be trusted also by people like these and usable for people like these? Can we have minimal training cost for them? Can the applications be easier than WhatsApp? Most of these people, what we figured out 2 years back, the survey, they didn't have smartphones, but today they are having some access to smart devices, many of them using WhatsApp as well. So from that perspective, how can we make the bar to include these people at the bulk of pyramid better from a vertical perspective like finance or banks? So can we have the next slide, please? The last aspect I wanted to touch was more related to cross-vertical with customer, regulator, and related aspects. Again, this was briefly touched in the previous panel discussion, but if we are designing open systems, we should also have rails where verticals can talk to each other. For example, today we have Arogyashri in Telangana, or we have Ayushman Bharat from national perspective and things like that, where a lot of benefits are targeted at people for the low income group and so forth. Now, these things are spanning healthcare, they are spanning transport logistics as well as financial systems. How do we make sure that the beneficiaries have access to these information or awareness, as well as the system as a whole minimizes leakages associated with these solutions? 5 years from now, almost all of it would be fully digital. So will our 6G platform make it more affordable and open and reliable for delivering such applications? To pick an example, in banking realm, because of lot of prior history, there is a very strong set of roles defined. There will be a proposer, there is a maker, a checker, and then there are multiple auditors, right? So all of this was built around a physical ledger, which has become more of a core banking solution today. Another thing that we are looking at is in future, when we are talking of such distributed systems, how do we audit it? Who will audit? This is a big challenge, and I hope as we're designing the next series of solutions, we are keeping audit as one of the goals in mind as well. Again, the last bullet here is giving some more reference on it. For example, today when we are trying to deploy applications in cloud, public cloud, one of the public cloud providers, trying to do an audit on their system is next to impossible. They may be willing to do a third-party audit, but when we ask them, can you prove that the data is deleted? While we had also told them that for business continuity, you have to create a number of replicas and so forth, very difficult to get those proofs out. So again, many industries have decided to keep data centers on-prem or trying to mix and match strategies based on how we will be able to satisfy the auditors or the regulator. And then the audit is not just about the data or software, it's also about the platform where we are running, be it an ATM or digital banking unit today, an IP camera, thermal sensors, biometric device, or a numeric keypad that goes into an ATM. The reason I am bringing up the numeric keypad here is when we talk of machine to machine or IoT scenarios, any communication going from an ATM numeric keypad has to be encrypted on the keypad itself to protect from the rare scenario where the ATM itself might have been compromised. Now, if you're trying to design solutions with such goals, can the open nature of the 6G system allow me to have this level of control to address the keyboard, the keys directly and communicate to it, while the currency dispensation is happening from the note cassettes and things like that, is something that we see it as possible. And we are also seeing the standardization communities coming up to enable these use cases. Just that the application perspective is probably as important as the communication perspective that we have been focusing on so far. Again, as closing remarks on the open part, we are one of the industries that has benefited the most from internet being open, UPI being a very good example. On the resilience part, we still have some scope of improving. To give an example, again with UPI's perspective, When there is a social unrest or when there is an exam in a particular state, we end up blocking internet and hence disrupting uh, digital India or UPI ecosystem. Now, slice as a concept exists in 5G. Would we be able to use it within the 5G realm, or will we have to wait till 6G? Let us see how it progresses. For enabling scenarios where part of the network continues to run even when we are shutting off regular internet. So with these thoughts, I would close here and we will continue to interact towards the end as Q&A.
Thanks, Abhishek, for yet another interesting thought and discussion on a concrete use case. Our next speaker, our next speaker is Mr. Amit Manocha, who is currently with TCS, and so he has been very active and also has more than 20 years of experience on related aspects. So I'll request Mr. Amit to share his thoughts now.
Yeah, thank you very much, and thank you, TSDI. Now, I mean, so far from the session, we clearly understood that we first understood that what is the internal component of 6G, whether it's a Mac or whether it's that various kind of models that how it is going to be implemented. Then we touched upon the ubiquitous connectivity aspect, intelligence, AI intelligence, and then we have two specific kind of use cases. Now, so one thing is very fundamental is there, though 6G or any kind of things has to be open and resilient, but how it is going to be validated ultimately, till the time it is not been consumed, you will never know that what should be the challenges. So here, what I'm trying to say based on my industry experience, entire ecosystem has to be connected. So otherwise, you will not be able to achieve that goal. And specifically from the 5G onwards, you cannot do the things in isolations. It is always be a collaborative approach, and collaboration is required. So here, I mean, what I have chosen few of the use cases, though, I mean, Dr. Lal has chosen about the invasive sensing use cases, and Abhishek has touched upon the banking sector problems. I have selected few of the use cases which are very much relevant to Indian context, as well as it has a volume, so that this openness and resilience can be tested. So if we take the three example, one is that urban air mobility. See, all of us are, I mean, you take an example of Bangalore, you take an example from Mumbai. These air taxis are there. But in future, by 2030, urban air mobility would be the realistic need of Indian context. It has a volume, and it has this eVTOL based mechanism is going to be established. So what would be the requirement of those kind of use cases? It would be very high precision positioning, seamless connectivity. I mean, it is not indoor, outdoor, but external to the outdoor. I mean, aerial views, and then real time controls. Similarly, online examination, all of you are aware, whether it's IIT or whether it's NEET, CUTE, or any kind of government railway exams. So much, I mean, masses needs to move from one end to another end. I mean, and the total cost of this conducting exam is very high. So maybe in future, this kind of online examination with the real controls could be one of the another use case. It has a volumes, very high speed of connectivity, real time alerts, everything is be required. And third use case could be the way Indian, you can say, economy is growing. Manufacturing would be the new definition of India. Manufacturing is required. We are already in talks in the chip manufacturing. Already there are several kind of manufacturing is happening. So industry 5.0 could be the reality for Indian context as well. So when we are talking about industry 5.0, it is all about that. Okay, so far everything is automated or autonomous, but with industry 5.0, it would be that, okay, human-centric knowledge can be collaborative approach. And then you need to continuously monitoring the various kind of activities, and you have much more stable decision making process. So this is all kind of, you can say, requirements where this open and resiliency thing has to be happened. So Akash, if you go to the next slide, please. Yeah. So some of this resilience and sustainability and openness of this 6G is, or I mean, features which are already available that can support this person. Ubiquitous or extreme connectivity. I mean, currently industry is facing one of the problems, whether I mean, you go to the many manufacturing setup or anything, you will see that, I mean, there is 3 wall, 4 wall penetration, your underground coverage is required. So ubiquitous connectivity can solve that problem. So importantly, you will get the seamless connectivity, and once you have the seamless connectivity, then you will get the real-time data uninterruptedly, and your models are going to, which is running on Mac or Edge, that is going to run on smoothly. Similarly, you take, I mean, whether it's a rural connectivity or semi-urban or remote connectivity or even aerial connectivity, there has to be a mechanism where your terrestrial and non-terrestrial network has to be integrated, and that is the feature of 6G, which is being, I mean, proposed. So ultimately, with these features, your deep-rooted coverage in, I mean, any angles, whether it's underground or aerial coverage, that is going to be managed through these things. And then it has a native diversified ecosystem. I mean, it is working in collaboration. I mean, it already started with the, you can say, in 5G ecosystem, where various kind of alliances has been formed, whether it's a 5G automotive alliance or 5G ACIA. So similarly, native diversified ecosystem and alliances are already started forming, and this there, I mean, the idea is to how do you accelerate this thing. ICT and OT operators can work together and come up with the right solutioning. Akash, can you go to the next slide, please? Now, only 6G network or is not going to be sufficient to set up this thing. Your ecosystem also required to play around on this. And it start with your even RF design, whether it's a chip design or whether it's a device design. Even that needs to be changed, because in terabytes of speed, your metal sensitive wiring or metal sensing circuits are not going to work. So you need to redesign your semiconductor itself. So its journey started from your semiconductor thing, and maybe the way antenna design and the way antenna material is being used, that is also going to be changed. Your metamaterials can be used for antenna redesigning, and the way arrays has been formed to create a beam formation, even that needs to be changed, or that is going to be modified. Similarly, on the security aspects, I mean, you need, I mean, as banking example, you have that. Then you need to include multilateral trust model inclusions, and it's a very high speed. Then you need to do this key distribution on the security part on a very quick manner, and that is the reason your quantum key distribution kind of technologies needs to be there. Your QNRG has to be there. Your PQC has to be there. So basically, to manage the volume on milliseconds, you need to design your framework accordingly, and that applies to security as well. And then transform network edge. I mean, as Sandeep was saying that, I mean, distributed AI has to be there. So, I mean, what we are actually talking is that we need to change our transformation from AI for edge to AI on edge. Means wherever is possible, wherever it is applicable, whether it's a device edge, whether it's a network edge, or whether it's an individual sensor edge, you need to put AI element into that. But how you are going to manage those AI and compute systems with power constraint and by battery constraint and link budget applications, that also needs to be thought of. But this is the way your ecosystem needs to play all these things. And the way of federated learning, I mean, in Dr. Slal, he was explaining that what would be the role of, I mean, haptics club. Their federated learning is very, very key important aspect. But how you are going to manage those federated learning, then ecosystem needs to work on that. And transfer learning, whether it's a knowledge distillation, everything needs to play a role. So in nutshell, totality is that not only networks which are, I mean, the beauty is that at least open and resilient part is in the network, but similar things needs to be applied to the entire ecosystem. They need to work on that part as well. Then and then this entire 6G become a reality to the society and solve the problems which we expected to be solved. So that's all from my side. Yeah.
Thank you, Mr. Amit. Thank you. So may I request Nishi to moderate the discussion session now?
Sure, Dr. Arsad. So, a couple of questions, Dr. Samar, starting with you, if I'm audible. So,
Yeah.
you mentioned, yeah. So you mentioned that 6G promises ultra low latency, high speed connection, ubiquitous connectivity, right? So many such buzzwords. So what challenges do you see in equitable access of technology for all regions and groups, and how can these challenges be addressed effectively?
Okay. So Nishi, a very interesting question, right? So, ubiquitous connectivity is something which we have been always working upon. It is not something that we never wanted it, but it's like chasing our own shadow. We are becoming more and more heterogeneous as we move forward, and more ubiquity we are trying to achieve. See, we had, when we looked at the 5G timeframe, we had a major challenge in terms of bringing the Wi-Fi and the cellular together. Now, when we are moving towards 6G, we are talking about the terrestrial and non-terrestrial being together. So I would say, given today's point of view, if we could achieve at least the convergence of satellites and the cellular and the Wi-Fi, we are good to go. But I'm very sure as we emerge further, towards 6.5G or 7G, we will start bringing more challenges like quantum into picture, the quantum communications, and all that convergence. So I would say, as of today, that's where we are. But
Hmm.
if you are asking me whether we'll be fully converged with respect to 6G, maybe not.
Okay, very interesting. So then I'll jump on to Professor Abhishek, who pointed out at how rural India can be impacted with 6G. So Abhishek, given unique challenges that we have, today in rural India, and the point uh, made by Dr. Samar about heterogeneity, etc., and how possibly 6G also could not be an answer to the challenges of ubiquitous connectivity. So the connectivity issues, the infrastructure limitations that rural India today faces, how 6G technologies do you think should be designed to ensure adaptability to deliver, reliable BFSI services or maybe health services, etc.?
Yeah, thanks, Nishi. Really loaded question. And what someone was saying, I will build upon it. It's a journey. Uh, the Western paradigms that we have had for connectivity may not work out for the global south. So while we will be leveraging more Wi-Fi and the interoperability and other aspects are part of the various discussions that we are having with 5G and 6G building upon it, the non-terrestrial networks surely should cover some of the challenges, though the cost and other things would be still something that is not really affordable for inclusion.
Mm.
One interesting thing we were having when we have been running a use case lab for a while is most of the needs from banking and even rural productivity scenarios are really not about that very fat pipe. It's about a pipe that can be more reliable, secure, trustworthy, and available,
Mm.
which may be at odds with all of our research challenges where we are trying to create more and more without trying to create solutions that are getting used better by 80% or 70% of our masses. So this is a contrarian view to a bit, but in the quest to get faster and faster, are we disconnecting part of our society? We have to be really thinking about it.
Right, I totally get that. So, thank you, Dr. Abhishek. So, jumping on to Sandeep, to you. So, what do you think? How do you foresee what specific enhancements do you foresee AI bringing to table? For network management, you've used words like intelligent, interoperable, virtual, etc. So, how do you think AI? What specific enhancements in AI are you talking about?
So if you talk about AI is not something very new. What we have to evolve with 6G is it has to be distributed AI. So if every node is taking their own intelligent decisions and we can collectively take a single pane of glass across different nodes, that will take up I would say, more real-time action from the operations and optimized resource perspective. And from the security perspective, if you say, uh, the enhancements of training the models and data collections will help in predictive measures to make the networks more secure and less vulnerable.
So you've spoken about native and decision-driven AI. So how's that different than the AI ML we see today in networks?
If you say the native AI is, I would say, fundamentally in the design, the AI exists. And if, for example, every node is taking own decisions, and decision making AI is basically you take a collective decision after collecting a data from different nodes. So it's more like uncollaborated AI. If you take a decision making, if you are native AI, it's more collaborative AI.
Okay, okay, understood. So that is quite explanatory. And then moving from here, you spoke about Open RAN. So what is the importance of openness in future networks? So we've been hearing a lot of things about how too many uh, a lot of impact can be made if the networks are open. It will be easier to deliver the possibilities that 6G promises if the network is open. So what kind of openness we are talking about, how important it is, and how far are we from that day to day?
So if you talk about openness is from different perspective. Open RAN Alliance talks about the different interfaces that can be made open and the new interfaces that can fetch data from different nodes and make it easily available for different developers for creating different applications like accepts and RFs. This is more on the openness, but the catch is not only openness; it has to be open and interoperable. So every, I would say, vendor can have a different interpretation of standards. If that standards interpretation is not aligned among different OEMs, the interoperability issue might keep on cropping in. So as we evolve towards more and more 6G, the interoperability is sort of, I would say, put as a fundamental thing while we're defining openness in the standards as well.
And how far do you think we are from there today?
We are not very far. I think OpenRAN has done a good job so far. Today, we see many networks are getting deployed. All majorly the greenfield deployed networks, the brownfield deployed networks, the enterprises type of network also looking at that because that gives the flexibility to deploy edge for the enterprise use cases. And as we evolve further, I think more and more openness will be there and the interoperability will be more mainline. Today, interoperability is there, and I think it will get more smoothen as we evolve further.
Thank you, Sandeep. So, Abhishek, I'm back to you. So, you heard what Sandeep is saying about openness, interoperability. So, what do you think the regulatory stance should be when you're talking about resilience, openness in 6G? We've seen some of it coming in 5G. So, what should the regulatory stance
So
be
it's
further
strictly
from
a
here?
personal opinion because part of my organization is under RBI, so I don't want to take any official stance here. Strictly personal opinion. When we didn't see a thing like CBRS succeed in India, I think we have lost an opportunity on multiple fronts. Uh, One is educating a good set of people. CBRS is a very good platform for campuses to leverage and train a lot more people on it. Uh, Picking up on what Amit was mentioning as a use case to conduct exams. Today, if telcos are the only carriers for networks for majority of India, we are not able to get cross vertical benefits. So if a bank is able to deploy part of the network, maybe cross subsidize or whatever, some business policies and models have to be built up, and the telco is able to leverage it, and the village is able to leverage it. Solutions like ORAN will really make it a win-win scenario. An exam being conducted in a school premise or even in a bank premise over a weekend brings down our capex, opex, and utilizes the resources we have much better for the community. These are some thoughts I'm bringing here again in personal capacity.
Yeah, I'm happy that they are your personal opinion because you are actually stealing away my salary from me. So, yeah, so moving further, Amit, on to you since Abhishek gave references to the use cases you spoke about. So, so the use cases that you spoke about were urban mobility, urban air mobility, to be very specific, the exams, etc. So, how do you think these use cases, what unique features in 6G could open up more use cases? And
See,
what are the challenges that could come up with this?
let me first address challenges because Abhishek mentioned the right thing. I mean, the way CBRS has been auctioned, similarly, if that kind of spectrum policies could be applicable to Indian context, then it's an easy thing. Now, the fundamental challenges would be that regulatory part.
Hmm.
What kind of regulations we are going to brought in without considering that too much? You can say usability of any kind of use cases or any kind of context information. You are just putting the regulation, then it would be very difficult. We have seen the example that DOT has not given a spectrum to the private players, right? So
Hmm.
that is one thing. Second, I mean, that is a regulation. Third is the second part is that if the ecosystems are not going to do the collaboration and they are working in the silos, then
Hmm.
it will be a challenge. Because you take an example of urban air mobility, right? So urban air
Hmm.
mobility will suppose be realistic and it is going to be till the time it is not on scale, everything is fine. The moment it is going to adopt the scale, then what should be the right additional frameworks which are required to monitor those things, to control those things? Then
Hmm.
I mean, that thinking has to be in advance. If that thinking is not going to be in advance, then it could be a challenge,
Hmm.
right?
So, yeah, I understand that. So, a lot of challenges that we are speaking about could be resolved with MEC coming in, haptics coming in. So, Dr. Samar, what do you think are the key differences between the edge that was a part of 5G and now that we are talking about 6G? What are the key differences? And I think someone on the chat also has put this question.
Well, yeah. So, edge is something which is very close to me. Dario made the presentation. He's my ex-colleague, and both of us have worked on edge for a long time, both at CMAC, 3GPP, GSMA, and so on. So currently, if you see, primarily I believe in 5G, the primary focus of edge is to put it together with the ecosystem. The entire focus is on opening up the APIs, make the edge more available, make it a way so that you have the framework available so that your intelligence can be communicated between the cloud towards the edge and towards your devices. So we are in a state of building the framework, and I think it's gonna continue for some time. We worked on the edge applications. We are trying to open up all these integration of these applications with the with the core network and so on. So we are in a framework building stage. Now, when we move towards 6G, we have very high constraints in terms of the latencies, the bandwidth requirements, and the availability of our applications. And I think as of today, what I see is the AI is going to play the major role. Okay, so how much AI can penetrate within my edge, so that the convergence of my communication and compute has to happen together, because edge is will become more compute intensive, but it will be very, very distributed. So the penetration of AI on the edge, the convergence of my compute and communication, and uh, bringing this natively into the framework, not as an overlay. That's what I've always been pushing. Bringing it as natively will be something which 6G has to achieve. 5G will lay the foundation in terms of only the framework. I mean, I don't see that happening even today, and it's not going to happen for at least, definitely not in release 19, because that's not the agenda for sure.
Okay, thank you, Samar. So, do you want to throw some light on the latencies between the two?
Between the two, you mean between the 5G and the 6G?
Yeah, yeah.
Yeah,
5G and 6G.
yeah, I mean, those are part of the specification. Like, for example, in the 5G era, we have been talking about the milliseconds latency. When you can, we move down to 1 to 10 milliseconds kind of framework. That's what we are trying to achieve. Uh, and 6G is gonna definitely be some millisecond latencies. Okay, and we are hoping, we want to support the, the use cases like holographic communication, like Professor Lal spoke about, the telesurgery and the digital twins and things like that. And we are also talking about a lot of intelligent applications on the edge. So we have to support this some millisecond latencies, and we can't have long range communication for sure. Whatever be your high bandwidth stuff, it will be very, very short range communications. So yeah, that's where we will be.
Thank you, Samar. So thanks a lot, all the panelists, and it was a very interesting panel. I'll now open the floor to the questions on the chat box. And okay, there is a question from Abhay: how to overcome DDoS and man-in-the-middle attacks in edge computing? And in 60 security, quantum computing secure as current crypto, and security algo can be easily cracked as okay. So what he means to say is that how do we overcome DDoS and man-in-the-middle attacks? And as quantum computing advances, there will always be chances of security algos to be cracked. So how do we do away with this? And Ishan, if I may ask this question to you.
Me, probably you're asking the wrong person, but we have a lot of work on post-quantum security that is ongoing. So we are already looking at, for example, algorithms that take into account the existence of quantum computing and how you can still apply cryptographic concepts via the quantum computing, including the quantum computing mechanisms in the team. But I wouldn't be qualified completely as a security expert to go into the details of that answer.
Okay, thank you, Ishan. So anyone else would like to take it up to go into the details? I think I missed looking at it. Sandeep, you've already answered this
Yeah,
part.
I already answered about it. So I think it's not only the quantum is evolving. What we are looking at 6G is not the current cryptographic measure. It's like post quantum cryptography. I think Ishan has touched it correctly. And to minimize the attacks, I think we need to look at the AI models to train or minimize the attacks. That's a one way of avoiding attacks, and using post quantum cryptography for security measures rather than using the current cryptography. And the question was correct. Quantum is evolving much faster way, so the security keys has to be evolved in the similar fashion.
True that. So, okay, so Vijay sir has a question to Professor Lal. What would be the order of reduction in latency in haptic edge systems, similar to what was posed to Samar? Okay. So, Professor Lal, are you
Yeah, so when
online?
we talk of latency, we must understand that there's this edge-to-edge, end-to-end latency, and then there's latency that actually operates in the system. So just as Sama's already said that end-to-end will be hard to achieve the number that we're talking of, the propagation delay will soon become longer than the latency requirements. So a more important question to answer here is the numbers are fine. We've talked of milliseconds. Will be down to a millisecond. But how will we achieve those? Because going right back to the controller and achieving a round trip of 1 millisecond will not be possible. So, I talked about intent prediction. That is a mechanism by which you already try to understand what the human controller might be trying to do, and information that is for later is already transmitted to the endpoint. So the endpoint will start doing some kind of an operation to achieve the final goal even before the human is able to send that to him. So latency numbers are fine. They'll be down to a millisecond. But what latency are we talking of? So the latency, I think, as we move on, there will be talk of latency with respect to different network elements, and there'll also be a talk of end-to-end latency. So for applications like haptics, for corrective measures, for emergency measures, there'll be one number, and for end-to-end there'll be another number. Uh, but hard to put the numbers there today. But yeah, but we must understand the way that's going to evolve.
Agreed, agreed. So I don't see any other questions on the question and answer box. So, okay, there is one more from Sandeep. When it comes to edge computing in 6G, will we have the facilitation of fog computing? Will there be more hierarchical structure in edge computing in 6G? So I think that could go to, I mean, one of the panelists or keynotes, please.
See, maybe I can try that. Maybe panel can add to it. I mean, sorry for jumping in when the word edge gets in, I somehow get triggered. Okay, so I would say as of today, right? We are looking at the edge. If we purely look at from the standards perspective, we are not going down, or we are not at least trying to go down to the level of fog computing. Okay. In fact, the way we are trying to do edge, we are trying to kind of, cover the scenarios of fog computing with the edge kind of architecture. That's how I see the thought process in the standards, the way they are emerging, at least in the 5G and 5G advanced scenarios. Whether it's gonna be hierarchical in nature, I would say it's still hierarchical. Okay, and it's gonna be like that. We are not saying edge is independent of the cloud. Uh, we don't have the capability to process all our AI models on the edge. So edge is both distributed as well as hierarchical. So there is no denial from that. I mean, in fact, not only from the compute perspective, even our applications are built both distributed and hierarchical in nature. What is going to happen in 6G, as I just mentioned, is that your architectures and your applications will get converged together, which is like the real convergence we are talking, where compute and communication gets converged, and also your application gets converged. I think that's the way it's probably going to emerge, but I don't know what really going to happen.
Right. So I think, Sandeep, you got your answer. So and sincere apologies. I think we are running out of time and taking more questions is going to be difficult. So I'll just go to the closing remarks. And for that, respected co-chair, Vijay, Madan sir, expert speakers, all the industry experts and members today attending this session. So as we are coming to the closure of this session, 6G Open and Resilient, I would like to take this opportunity to reflect the wonderful talks, the discussions, the panel we've heard today. We've delved into almost all aspects of 6G that contributes to resilience and being open, and most of all, how it could be accessible network or accessible connectivity for the rural Bharat. And over the course of the session, we've touched upon very important topics like MEC, APIs and securities, relevant threat mitigation mechanisms, Open RAN, the role of native data-driven API, diverse and really new use cases that 6G could bring upon, and the potential impact of 6G, that can happen as we take it to further stretches of rural India. Rightly pointed out by almost all the panelists and the keynote speakers here, MEC and haptics are a foundational stone, and so is Open RAN. And that is how we are going to deliver the promises that 6G makes towards speed and latency. However, having said that, it cannot be achieved in isolation. The ecosystem, the regulatory, the telcos, hardware OEMs, software developers all need to join hands together to make this happen. Samar and Ishan, they both rightly pointed out the reaches that 6G will go to, but the complexity is also involved with that. And how do we mitigate all of that and bring robustness, resilience, and ultimately the impact that 6G can possibly make? Thank you, Sandeep, for throwing light on Open RAN and how it transforms the network architecture to become more intelligent and smarter than ever. And amidst all of this, Abhishek, thanks a lot for throwing light on how 6G could be a path to reduce digital divide. Once again, I would like to thank everyone present in this session today and enlightening me personally. I feel totally much more educated now than previously. Thanks a lot, everyone.
Thank you.
Thank you, Nisha.
Thank you, Nishi.
Thank you, everyone.
Thank you.
Thank you, everyone.
Thank you.
Thank you. Bye bye.